Hello, everyone. I know it's week 5, and we are going to do some text reading and answering of questions based on the information from that text while we're in class this week. So I wanted to, even though we're going to talk about it in class at length, and I'm going to read through it with you, I'm going to give you time to read it on your own or listen to it or both. However, I know it helps our brains if we have multiple times that we can interact with text material. Sometimes it gets hard to just read the whole thing and just want our brains to remember everything that's in there. So that's why we call this thing chunking. If you chunk parts of the text, which means read it and then stop and think about it or do something with it, and then help make connections in your brain with what that means. So I'm going to read this to you, and I know that you can read it on Google Read Write because you've all learned how to listen to text PDFs with Mr. Leach's class. There are other PDF read alouds. I know some of you use Learning Ally. However, I just want to provide this extra resource if it will help you. So I'm going to read through it, and I'm going to stop at each paragraph. We're going to call each paragraph a chunk so it doesn't get overwhelming, okay? So we're going to start with this first paragraph. Last week, we learned how NASA lost the Mars Climate Orbiter about 20 years ago due to mistakes in measurement. And then I attached that video from class if you missed it or just wanted to see it again. Measurement can be defined as a repeatable observation of a quantity that includes a number and a unit. Often, we try to guess what the measurement of something is. An estimate is a reasonable guess based on an observation. When you make and record measurements, you must also record the units. It is like the last name of the number. A number by itself is not a measurement. It must have a unit to describe it. So let's stop there for just a minute and just look here at what we just read, this first chunk, okay? So if you look back through it, one of the things that pops out is there's a link to a video, and then you can make a decision if you want to watch that. The other thing that pops out is that there's 2 bolded words. So when you see bolded or underlined or highlighted words, that means that they're important, and you should probably make sure that you know what they mean. So you can use your Google Read Write and maybe highlight what measurement is. You could highlight what an estimate is, okay? So then we would go back and we'd be like, all right, well, we're supposed to know what these 2 words are. So we might reread the definitions, and we might see what else is available in this paragraph. So it seems like we were given the definition of the word measurement. We were given the definition of the word estimate. So you know when you estimate something and people say, how long is it going to take you to get here? And you're like, about 20 minutes. That's an estimate. So the same thing works when we're measuring things for science. We can estimate before we make that actual measurement. And then finally, this paragraph stops or concludes with how important a unit is as almost a last name for a number. So there's 3 important things we can get from this one chunk paragraph. So then maybe we stop for a minute, we get a drink of water, we take a break, take a deep breath, and we move on to our second chunk. Here we have the second paragraph. Scientists worldwide use the SI system of measurement for all work. SI stands for Système International, which is French for international system. Last week, we learned how the metric system came after the French Revolution, or around it. Here is the link again for that integration with history if you missed it or just wanted to see it again. Each type of measurement in SI has a base measurement, like meter for distance. We might use mile for distance. Prefixes are added to show the multiples of that unit, like kilo, meter, or fractions of that unit, like centimeter. All prefixes and fractions use powers of 10. The SI system is an updated version of the metric system. Watch the following introduction video on the SI units. Some classes watched part of this last week. If you on your own completed all 4 videos from the intro to measurement last week, you may have seen this. It's very short. If you don't remember anything about SI units, you might just click on it for a little refresher. So now we stop again and we look at our second chunk of information here, okay, our second paragraph. Do we see any links like we saw in that first paragraph? Yes. So we see a link for if we missed something or wanted to go back, and then we see a reminder link on the SI units. Do we see any bolded words or anything else like that? Looks like I see one bolded word. I do see one word in italics here, but it looks like it's just explaining the bolded word. So this is our third one. This is the International System of Units. And then it looks like the rest of the paragraph goes on to explain what that bolded word is. It is confusing, so don't worry. We're just introducing you to using the metric system, okay? So if you have heard of a kilometer, meter is the base unit, and the kilo in the front, like here, this word, is the prefix. Anything that goes in front of a word is a prefix. So that means larger. It's larger than just this base unit meter. Now we also have this one over here, centimeter. You may have heard that, or you'll see it today probably in your class or when you have class this week, as we will practice using some centimeters. So again, we see our base word meter, but then we see this prefix in front of it for a fraction of a meter. So centimeter means 100th of a meter. So again, you're not supposed to know or memorize all of those different prefixes and things. We just want you to recognize these bolded words, and we are providing this text to help explain where it all came from and what it means. And then we stop again for a minute and we look that we have a little bit more information down below. Maybe again, we've done 2 chunks, so maybe we stop for a minute, maybe we get a drink, maybe do a different activity and come back to our reading just to take a deep breath. So we're about halfway through, and what we see here is an introduction to this whole last part of this reading. It says we will focus on 5 units: length, volume, mass, temperature, time, and density. That looks like 6. 1, 2, 3, 4, 5, 6. We will focus on 6. Sorry for that typo. So the first one that we will focus on is length, and you can see right away that this intro sentence, then below that you have those 6 topics all bolded for you, so you can draw the conclusion that each paragraph is going to tell you a little bit about each one of those. So for example, this first one here, okay, it tells us length is the distance between points. The meter is the base unit of length. The most common unit larger than a meter is a kilometer. It is shorter than the mile. Common units that are smaller than the base unit meter are centimeter and millimeter. They are on a metric ruler and can be compared to our inch. Again, we'll practice with those today. Tools we use to measure length include a ruler or meter stick. So then I stop. I don't continue reading. I stop and I look back at this third chunk that I have read, and I see what it has told me. It has told me that length, it has given me a definition of length. It has told me the base unit. Like, what do you measure length in? And then it goes on to explain that a little bit and talks about the tools we might use. So 3 things in that chunk about length. So our next one here is mass. Mass is a measure of how much matter is in a solid, liquid, or gas. The base unit is a kilogram. That is like the US using pounds. Smaller than the kilogram is the gram. Mass is not the same as weight. Weight adds in gravity. You would have the same mass on each planet, but a different weight. And then you see a link for watch. You can use a triple beam balance, pan scale, or digital scale to measure mass. So we look back here again at this chunk and we see it has given us these bolded words, mass and kilogram. And then it's given us a video to deepen our knowledge here about why mass and weight are different and what that might look like on the different planets of our solar system. And as we get closer to the bottom here, we have time. Time is measured in seconds. It is defined as the duration of an event. So duration means how long something lasts. Tools such as stopwatches can measure time in milliseconds, seconds, minutes, and hours. So this is a very short chunk of information. It gives us 2 bolded words to help us know that they're important. It gives us a definition, tells us what tools can be used to measure time, and then some units, milliseconds, seconds, minutes, and hours. So when something's familiar like this, you might think about what questions you might be asked about it as you're reading it. Next, we have temperature. Temperature is experienced as hot and cold. We use a liquid thermometer to measure precisely. The liquid expands when it heats up. Scientists use the Celsius scale, but we most often hear our weather reported in degrees Fahrenheit. So most of us have experience with the forehead thermometer, especially with what is going on with COVID and the coronavirus. So in science, most of the time we're not measuring the temperature of people or animals. We are measuring the temperature of substances, liquids, things like that. So we would use a tall, skinny thermometer. You'll see one here in this practice. And most of the time it has a liquid in it that would expand as it heats. So as it expands, it rises. And then as it rises, we see that as a higher number and think that it gets hotter with that higher number. Those liquid thermometers do use the Celsius scale. The Celsius scale is nice. It goes from 0 to 100. 0 is freezing, 100 is boiling. So a little bit different than what we currently use. And almost done here, we have our second to last chunk of volume. Volume is the amount of space an object takes up. We have used milliliters in class so far. So when we did the Alka-Seltzer in the plastic bag, I explained to you the 25 milliliter measurements. A liter is the base unit. Most soda bottles that we know are 2 liters, so you are familiar with this measurement maybe more so than other parts of the metric system. There are several tools that can measure volume in science. You have seen the graduated cylinder, beaker, and a flask. If we want to find the volume of something that is not a liquid, but doesn't have even edges to measure, we use something called water displacement. And what we have here is a video to see what that means, and then even a link to practice it. So then we stop, even though we're almost finished, and we look back at this chunk of information. We see a bolded word volume, the definition. We see the base unit is also bolded as it has been in the other chunks. Gives us an example, the tools that measure volume, and then even a whole new way to measure volume that maybe we haven't seen before. And then our last chunk of information here is on density. Density is a calculation of mass divided by the volume. That means it is how much matter is packed into a certain volume of a substance. Have you ever picked up something and it was much heavier than you thought it was for its size? Picture something small but heavy. We might think that is how you might think of the word dense, heavy density. Or if some of you have talked about traveling to Florida and humidity in the air, so that would be a dense air if it's thicker. So we will do a little bit introduction to that as well. That's your final chunk of information on this page. So we kind of always want to go back up to the top and then kind of review and think to yourself, what is it that I learned from this information? And so you kind of re-skim the information, maybe check back on those bolded words, watch any of the video links. The first two are optional because you may have seen them already in class. But these bottom ones are new information. There's 1, 2, 3, 4. So there's 2 short videos and 2 practices. So you'll actually get to you'll get to guess at reading the thermometer, and you'll get to guess at using the water displacement to calculate volume. Okay, these are not assignments, these are for you to practice so that you don't worry about getting anything wrong. Okay. When we have finished reviewing this in class, there will be an assignment to help us maybe take some of these words and make them smaller. We don't want to have to reread this every time. Part of a study skills in school is writing notes, and I know many of you don't like that idea. And so what I would like to teach you this year is how to pull key information out of a piece of text like this so that you're only then looking at those just key points. So we'll practice that in class today.